In this video, we're going to talk about composition of functions. So we've been looking at functions that are transformations of numbers. They take one number and they transform it into a new number. Well, if the input is a number and the output is a number, that means the output of one function could be the input of another function. And that means we can chain the two functions together. So we could take one function, apply it to a number, produce a new number, take that number, plug it into the other function, produce a new number. And what we've done is we've created a new function. That new function that we got by chaining these together takes that one first number and produces that new number. That's a new function. We call that the composition of the two original functions. Okay, so let's look at this with some mathematical diagrams here. Here we have a diagram depicting a function g. So we see g has a domain and a range. It's going to take values from the domain and it's going to produce values in the range. So it's going to take a value x over there, and when you evaluate x with the function g, we get a new number called g of x. All right, now imagine we have another function, f. All right, so f has a domain and a range, right? So it's going to take numbers in its domain, which we're going to call y, and it's going to produce new numbers in the range, right? So if I take a y and evaluate it at f, I get a new number called f of y. Now what we're going to do is we're going to put these two functions together. All right, so let's combine them. We're going to make the domain of f align with the range of g. So let's see what happens. If I take a number x and evaluate g at x, I get g of x. And now I'm going to plug that into f. So I'm going to evaluate f at g of x. And I get a new number called f of g of x. This transformation that took x to f of g of x, we call that the composition of f of g. And we denote it like this, f circle g. Now let's go through this thinking of an example. So suppose I'm thinking of a circle whose radius changes over time. All right, so g is going to be the radius of the circle at time x. All right, so if I pick a time x and I evaluate g at that time, I now have the radius of the circle. Now suppose the radius is given by 3 minus x over 2. Okay, so that's g of x, the expression 3 minus x over 2. Now from the circle, we can compute, for any radius, we can compute an area. So that's a function. Suppose that f gives us the area of a circle of radius y. So f transforms radii into areas. So if I give you a specific radius y, f will produce the area of the circle. Now we happen to know the formula for the area of a circle for a given radius. We know it's pi r squared. Here the radius is y, so it's going to be pi y squared. So let's put these two functions together to find a function that gives us the area of a circle at any time x. All right, so we'll combine these, and we'll take that time x, and we'll compute the radius corresponding to time x, and that is going to be 3 minus x over 2. And now we're going to compute the area corresponding to that radius. And that is going to be pi times that radius squared. This function is the function that transforms time into area. At any time, we know the circle, at any time, we know the area of the circle at that time. Okay, here's a couple functions. Let's practice doing some function compositions. Let's compute f of g of x. Okay, well, how would we do that? Well, we know that that is f evaluated at g of x. What that means is I'm plugging g of x in place of x here. See, I'm putting it in place of the x. There is now a g of x. So everywhere I see an x over here, I'm going to put a g of x. So this is equal to 2 over 3 minus g of x. But what is g of x? G of x is x squared over 5. So this becomes 2 over 3 minus x squared over 5. All right, let's try it the other way around. Let's try g of f of x. Well, that's going to be g evaluated at f of x. Okay, well, what does g do? G takes x, squares it, and divides by 5. But in place of x, we've put an f of x. So instead of x here, we're going to have an f of x. Right? So it's going to be f of x squared divided by 5. Well, what's f of x? F of x is given by 2 over 3 minus x. So in place of this, I'm going to put 2 over 3 minus x. And there we have it. Okay, we could do some other things with these functions. We could do f composed with f of x. We could compose f with itself. Well, that's going to be f evaluated at f of x. So in place of the x here, I've put an f of x. So in place of the x here, I'm going to put an f of x. So this is 2 over 3 minus f of x. But what's f of x? F of x is 2 over 3 minus x. So what we have here is 2 over 3 minus 2 over 3 minus x. And yeah, you could probably do some simplification here, but I'm going to leave this like this just for the sake of expediency here. G composed with g of x. Let's try this. Well, that's going to be g evaluated at g of x. Well, I'm plugging g of x in place of x. So I'm going to put it over here in place of x. So I'm going to have g of x squared over 5. But what's g of x? G of x is x squared over 5. So in place of g of x, I can put an x squared over 5. So this is going to be x squared over 5 squared over 5. And I'll leave it as an exercise to you to simplify this. You could do quite a bit of simplification here. Okay, let's look at another example where we're looking at the graphs of the functions. So here we have a graph of f, here we have a graph of g. Now what I want to do is I want to compute f of g of 3. All right, well, what we're doing is we're plugging the 3 into g. And then we're going to plug that new number, this is going to be a number, we're going to plug that into f. Okay, well, let's compute what g of 3 is. Well, when x is 3, the height of the graph is g of 3. Well, the height of the graph is 0. So g of 3 is 0. So that means that this is the same as f of 0. What's f of 0? Well, that's the height of the graph above 0 for the graph of f. The height of the graph above 0 is 1. So f of g of 3 is 1. Let's try the next one. G of f of 0. Well, let's compute what f of 0 is. All right? F of 0 is the height of the graph of f above 0. Above 0, the height of the graph of f is 1. So f of 0 is the same as 1. So what we're really computing here is g of 1. What's g of 1? It's the height of the graph of g above 1. Well, that's 5. So g of f of 0 is 5. There are a couple other questions down here. Let's try f of 4. Okay, well, what's f of 4? Well, f of 4 is the height of the graph of f above 4. Well, that's 5. So f of 4 is 5. So that means that this is just f of 5. This whole thing is 5. So f of 5, what's that? That's the height of the graph of f above 5. And that is 3. So the answer here is 3. Finally, we have one more, g of 1. G of g of 1. Well, g of 1, what's that? Well, it's the height of g above 1. So here we go up to the height of the graph of g above 1. That's 5. Okay, so g of 1 is equal to 5. All right? So this whole thing inside here is a 5. So we're really just computing g of 5. Well, what's g of 5? It's the height of the graph of g above 5. So I'm going to go over here above 5, look at the height of the graph of g. I see it's equal to 2. So g of 1 is equal to 2.